using a dialogue system as far as I could get it. And the talk will be given by Oscar Lithgow-Serrano. The co-authors are Denis, Broggini, Giancarlo, Corti, Luca, Chiarabini, Daniele, Puccinelli, Fabio, Rinaldi, and Andrea, Laus. So Oscar, the floor is yours for about 15 minutes so that we then have some time for questions as well.
Yeah, sure. Thank you. Well, yes, I am Oscar Lithgow, and I'm presenting today the project named Boosting the Quality of Experience of a Leadership Training System with Natural Language Processing, or in short, BOOST. This work has been conducted by the University of Applied Science, SUPSI, jointly with the company Lifelike as part of an Innosuisse project. So, okay, what is SkillGym? It is a computer-based training environment focused on helping to develop communication skills. These skills are trained through a series of conversations where the user plays the role of a manager facing complex situations with her employee, for example, which is played, the employee is played by the simulator. So the simulator behavior depends on the user responses to the conversation flow. And so this let the user witness the impact of her communication choices and associate them to specific patterns. After each training session, the system provides some feedback to help the user to understand the areas of opportunity to improve her way to communicate with her employees. And to achieve this, the SkillGym system integrates several key elements, like, for example, real actors, interactive simulations, and remote monitoring, among others. So the SkillGym experience starts from a smart scheduling model, a preparatory information to contextualize each session, and then the interactive conversation itself, and followed by a feedback. But now let's focus on the conversation simulation. So first, it is worth mentioning that there are different situations, but also different characters with their corresponding attitudes, emotions, and in general, ways of being. So this is something important to consider. So all these elements already create a very rich and engaging environment. However, the user interacted with the system by pointing and clicking within the interface. This reduced the realism that the user perceived. That's why we started this project, the Boost project. So basically, the goal of the project is to boost the quality of the experience of the user with a combination of a base, of a voice-based interface, and some NLP techniques as well to create this improved experience. So with the voice-based interaction, the user now is expected to be free to express herself in her own words. And with some NLP techniques, we try to provide a system with some capabilities to respond in a smart way to the user utterances. So now, instead of doing a point and click on the different options in the interface, the user can now respond to a conversation just speaking to the simulator. So just in this screenshot, we can see that he just needs to push the button and start speaking. Then the system processes the utterance in the background, and the conversation moves forward according to the interaction. what were the challenges that we faced in this project, or we are facing in this project? Well, first, we have different characters that are designed to have different ways of being, as I already said, different vocabulary, and even different training objectives. So that also means that there are the specific blueprints and specific logics to the SkillGym DST, I mean the dialogue state tracker model. So basically this boosting of the project have to be designed to be integrated and cooperative with the other already existing models. Second, we have very small data sets, just in the order of hundreds. And finally, we have to deal with transcription errors from the ASR system. So now I'm going to briefly go through some of the tasks that we have included in the system to reach the project goals. That is, give the user a more natural sense of interaction. So here it is a chart with the general steps that are involved in one user simulator interaction. So that happens many times during a conversation. So everything starts from the user speaking to the simulator as a response to a part of the dialogue. Then the simulator pass the recording to the speech-to-text model. In this case, we use Google, and also to the DST that is part of the already existing system of SkillGym. Then the DST, the dialogue state tracker, builds a working context based on the blueprint, the character, and everything else. And with this working context, it is used as an input to the next steps. And these next steps are the transcription post-processing to generate an utterance, and then the analysis of that utterance to create the response, to pass it, to return it to the DST model, and then this model is going to handle the next video for the user. The working context contains the user utterance and some other texts that the SkillGym DST provides as a contextual information. So now I'm going to go a little bit deeper on two of these steps, the transcription preprocessing and the utterance classification. First, the transcription preprocessing, this one that it's highlighted. Well, basically, this transcription post-processing means to process the transcription that comes from the ASR system. But why? Why do we need to do this? First, because the ASR systems are far from perfect, not even Google. So that is the system we are using is Google, and we have faced several and sometimes surprising mismatches in the transcriptions. Then clearly this is related to the fact that we are dealing with non-standard English, I mean different accents, different language variants, plus non-native speakers as me. So if you put all this together, it becomes a challenging scenario. And also, it is important to do this because this is the first step into the pipeline. So these transcription errors are propagated downstream through the pipeline. Then, what are we dealing with? What are we tackling? We are tackling nonsensical utterances, these kind of utterances that are intended to attack or mess around with the system, like the user is trying to test the system, how smart it is. Second, we are dealing with incomplete utterances due to the lack of time, because there is a predefined time where when the user can speak and give his utterance. So if the time runs out, the utterance can be broken. And also we're exploring to deal with spurious word corrections, which means words that were misunderstood by the ASR. What are we not dealing with? We are not dealing with incomplete transcriptions due to pauses or long fillings, like for example, I don't know, my name is whatever. Or we are not dealing also with transcriptions that are totally different from what the user intended to say. For example, there is an example here. The blue thing is, the blue box is the original recording from the user, and the other one is what Google comes from with as a transcription. Okay, so how we do it? So we applied for the detection of broken utterances, we applied a simple rule-based strategy. It is based on the grammatical categories and lemmas at the last n-grams of the utterances. And here there are some rules that we are using in this model to detect these broken sentences. Like, for example, if the sentence ends with a conjunction or with possessive determiners, or for example, ending with an article, etc. We also try to use a BERT-based classifier, fine-tuned on to classify based on the COLA corpus, a corpus that is aimed to detect unnatural sentences. But the performance was even better with the rule-based strategy. The second step was to complete these broken utterances. Again, we try to be conservative in our approach, in the sense that we want to go carefully on putting the words or some words in the mouth of the user. So because of that, we actually use it again, an heuristic. It is based on detecting the n-grams from the ending n-grams from an utterance, and then searching in a reference sentence the longest similar n-grams. And with that, we come with a candidate to complete the sentence. At the right, we have some examples. For example, the broken utterance is, "Hello, Bob, how are you? Nice too." And from the reference sentences that comes from the working context, we detect that a possible candidate is "see you." And we use it as to complete the broken utterance. The other thing was spurious word corrections. It's an experimental feature. So basically, we try to detect the spurious words using an heuristic based on word frequencies, using the blueprint vocabulary and some homophones. So if with this, we try to detect the utterance, the words that are spurious within utterance. Once this is only how good is the detection in a very small data set that was artificially generated. We are getting a F1 score of 0.8, and then we try to correct them using following a very simple strategy. We mask those words that were identified as spurious, and then we pass that masked sentence to BERT, and we try to restrict the candidates to some kind of preferred candidates. And these preferred candidates come from the intersection of homophones and the blueprint vocabulary. So this gives some nice results, as you can see at the right, as there is an example there. And yeah, that's mainly that part of the system. Then, okay, now I'll move to the utterance classification step. This comes after the transcription produced by the ASR. So the input is for this utterance classification is the post-processed utterance and the working context. This one. And so one of the objectives of this analysis is to is to provide information that could be used by the SkillGym DST to correctly respond to the user interaction. But also another objective is to detect if what the user tried to express was not a direct response to the conversation, but a command or for the simulator or an opinion or other types of deviations. So this step is based on some features that I'll mention in the next slide and a couple of models that try to do the classification, specifically to detect nonsensical instances and to classify intents. So the features that we are, some of the features that we are using are acceptability probability, that we are using BERT for that, trained on the Cola corpus. We are using the tail-child readability scores, Rouge scores, paraphrase probabilities. These are when comparing the utterance with some working context, some semantic textual similarity metrics, and also similarity metrics on distilled version of text. So just some details about the features that I just mentioned. The similarity, for the similarity we use BERT. Yeah, for the paraphrase as well, but trained on the MRPC corpus, and the distilled version of the sentences that we are producing. It is just a very basic and naive example approach to extract the subject-verb objects from the utterances. This is just some results from the nonsensical utterance detection. I'm going to go a little bit faster. And then now I'll give a very fast overview of the intent classification. So we approached this step as a common classification problem, where the goal is to classify the utterance as one of the intents that the system can handle. So for that, we follow an already proposed schema of intents that it's called MIDAS, and we generated this taxonomy of intents. In one branch of the taxonomy are functional requests, like incomplete requests, diversion requests, social conventions. For example, in diversion, we found offensive language and jokes and things like that. And in the other branch of the taxonomy, we find taxonomy requests, semantic requests, sorry. For example, when the user wants to express a command or want to express a complaint. So because we didn't have data for train a model on this on all these intents, what we did was to use a lot of existing data sets with different type of intents, and we manually selected which intents from which data set was useful for us. So we collected a Frankenstein data set, and we come up with 25 intents. This is some of the results of the intent classification. This is the confusion matrix and some scores. As we can see, there is the results are good for this task, and we have some confusion, some intents that are not so well defined at the top left of the confusion matrix. But these are intents that are really tight correlated. So it is not so bad that they are sometimes not so well defined. And so with all that, we finished the loop of this interaction between the user and the simulator in each interaction of the dialogue. All these features and both classifications probabilities are passed to the DST of the simulator. So the simulator select the corresponding video and moves forward in the conversation. So just a note, this is not a task-oriented dialogue because we are not doing a kind of flight reservation or whatever. And yeah, basically it's that, and thank you very much.
Okay, thank you very much, Oscar, for the presentation. We have a couple of minutes left for some questions so that we still fit in our slot. So from the audience, I suggest either you pick up the microphone or you write your question. So please let the first question come up.
I'm happy to ask a question. So thank you for the presentation. This is a really interesting project. So it seems like the different steps that you perform, they all have quite decent performance. I'm interested in the overall pipeline. How well does it actually work, and how have you evaluated that?
Yeah, that's a very good question. But the thing is that this is a new interaction of the system, so we don't have data to evaluate how well the system is behaving with all the pieces together. So, but now that we have all the pieces together, we are starting to collect some data, some real data, and we are in a kind of debugging mode where the people who is trying the system is evaluating the interaction, their own interactions. So we are going to end with a bunch of real data to evaluate the full pipeline. Yeah, but it's a very important step. It's the next big step.
Okay.
Yeah. Thanks for the presentation. Yes. Oscar, you mentioned that this is not a task-based dialogue. So I wondered, what were the difficulties and your main lessons learned building of this system and working on this project in comparison to doing a task-oriented dialogue, like a flight reservation or train departure times?
Yeah, well, I think one of the main difficulties was the lack of data for training, because it is not a task-oriented. We don't know what is the next step or the things that we want to qualify in the user utterance. And the other thing was to really know the data and really know the domain. So we go for the old-fashioned NLP, as Claudia already said, because it was very important to also integrate the expert knowledge into the different steps. So I think those were the main challenges for this.
Okay, I have a short question, if I may. If I understand well, the system in the end will select one of the predefined answers because we have a canned scenario somehow. So what is the need for this rather complex processing if in the end the task is rather simple? Basically, we have to match the user's utterance with one of the maybe, I don't know, 3 or 4 canned responses. So did I understand well, or is it more complex than that?
Well, yeah, it is a little bit like that. But do you mean that the complex scenario about comparing the utterance with all these predefined options? Why to do that? Mm-hmm. Or, well, basically the purpose was to give the user a more natural feeling of the interaction, and really to leave him like freely speak and express himself, and also, as I said, we have to deal with the already existing state tracking of the SkillGym system. So this has to be integrated with that. We weren't building a complete new system. It was just an upgrade. So I don't know if that answered your question.
Yes, I think it would be interesting maybe at some point to do also the dialogue state tracking without the cleaning, for instance, and just see how bad it works, and this would even more maybe justify the operations that you present.
Yeah. The other thing is that we pass all these results to the other model of the system that do the analysis to give the feedback. So this the feedback has to have like good input to come with some meaningful things to say to the user in order to suggest some improvements in his way of communicating with the employee.
Okay. Yeah, thank you.